All right, everyone. So, if it's a little small for you to see, just remember you do have the study guide yourself, so you can look at that, and it's also online. But let's look at 21. So 21 says we're looking for a function where f prime of x is less than 0. And in other words, we're looking for a graph who has a negative slope. So that eliminates a, that eliminates b, and that eliminates c because all of those have positive slopes. So now we're only looking at d and e. From there, we need where f double prime is greater than 0. And that means we're looking for, between d and e, which one is concave up. And so let's just look at that basic concave up shape. It's this. And so if you can look at that, if you can just imagine, is there a portion here somewhere that looks like either D or E? And it looks like right here, if you take that portion of a concave up, you get D. So the correct answer is D. D is a concave up shape, and the slope is negative. So specifically, it's like you're taking that concave shape and just cutting it down to be that much. Up next, question 22. We have two graphs, a graph of f and a graph of g. And it says that h is g divided by f, and we need to find h prime at negative 3.5. So that means when we derive h, we're going to have a quotient rule. And I know there's that comma there. It's supposed to be a comma. I know it looks like maybe it's a prime of f or something weird like that, but it's supposed to be a comma. Anyways, so when we derive h, we're going to bring f to the top. We're going to derive g. Then we're going to subtract, and we're going to derive f and keep g. And that's all over the bottom squared. So f of x squared. Now, what that means is we're going to need to look at these f graphs and g graphs and figure out what the value of f is at negative 3 over 2 and the derivative of f at negative 3 over 2. We're going to need to know the derivative of g at negative 3 over 2 and the value of g at negative 3 over 2. So, at negative 3 over 2, in other words, negative 1.5, it looks like on f of negative 3 over 2 is 9 over 2, or in other words, 3.5. Wait a minute, that's 7 over 2. And f prime at negative 3 over 2 at negative 1.5. Let's see here, that's the slope of this line segment, and that slope is negative 1. Now, what is g at negative 3 over 2? Let's see here. It's 3. And g prime, the slope of that segment at negative 3 over 2 on g, looks like positive 2. All right, so let's plug all this into our quotient rule here. So we have 7 over 2 times g prime, which is positive 2, minus f prime, which is negative 1, times g, which is 3, all over 7 over 2 squared. Let's see if we can simplify that. That numerator is going to be 7 plus 3 over 49 over 4. So that's 10 divided by 49 over 4. And when we keep change flipped, that's 40 over 49. Up next, question 23, I can kind of tell you was a hard one to write because, again, it's going to be multiple choice, and it's hard to do this question without writing the multiple choice answers. But let's see what we have here. We have f is concave up from 1 to 4. I'm just going to draw a random graph here, or a set of axes. And we have the equation of the line tangent to f at 3 is y equals negative 4x minus 2. Now let's see here what that means. If x is 3 and that's the line tangent, I can plug 3 in and figure out what the y value is of our function at 3. And it looks like that's negative 12 minus 2. I get negative 14. So just to sketch this out, here's a point 3, negative 14. We also know the slope tangent here is negative 4. It's going to look something like that. And we also know that the graph is concave up on this interval. So if the graph is concave up on this interval, I know the graph has to look something like that. Or at least, zooming in really close here, maybe it doesn't actually have to bend up at all, but it is going to be part of a concave up portion, kind of like what we saw in that example earlier. So somehow that's what f looks like around here since it's concave up, because if I try to draw it on the other side, being tangent on the other side, that would be concave down. So What can be said about the values of f prime over the interval 2.9 to 3.1? Well, let's see here. F prime is negative, but it's getting less negative. So f prime of x, let's see here. We can maybe say it like this. F prime of x will be less than negative 4. It will be more negative from negative 2, or sorry, from 2.9 to 3. Or you could use interval notation. And f prime of x will be greater than negative 4, in other words, less negative, from 3 to 3.1. This is definitely probably one of the hardest questions that you'll see just because of how abstract it is. Now, I think it will also be easier once you have the multiple choice answers that you can kind of weed out. But the important thing to be able to do is get that basic idea of what the function looks like. There's the tangent line, there's the point on the graph, and because it's concave up, it has to be on, like, I guess the right side of that slope of negative 4. If it's on this side and it's tangent, that's a concave down section. And from there, again, you can see, well, if the slope is exactly negative 4, it has to be more negative to the left of this section, and it has to be less negative to the right of this section. Back to no calculator, even though the calculator didn't really help us on this section anyways. We've got some, I guess, in the grand scheme of things, after all we just looked at, I think these questions are a little easier. We just have to derive f prime, but we do have a chain rule. So deriving that, on the inside, you're going to get 20x to the fourth. And now we're done with the inner derivative because 2 derives to 0. Then we're going to do the power rules. We're going to drop the 7 down. We're going to put the algebra back inside, 4x to the fifth plus 2. And now we reduce the power by 1. And probably the only other thing you'd have to do here is simplify and write 140 x to the fourth, 4x to the fifth plus 2 to the sixth. So I would call this a basic chain rule question. 25 is going to be a chain rule question inside of a quotient rule. Actually, it's kind of just a quotient rule. But let's see here. Because we have that quotient and we want to derive it, we're going to bring the bottom to the top. Then we're going to derive the top, which will derive to negative 1, minus sign. Now we're going to derive the bottom, which will be 4x cubed, and the 7 derives to 0. And then we're going to keep the top, which will be 3 minus x. And that will be all over the bottom squared. Now, your answer choice probably won't look like this in the multiple choice. What will they do? They'll probably combine some like terms here. So let's work on the numerator a little bit. You will get negative x to the fourth minus 7 up front. You'll still have that negative. So let's distribute the negative 4x cubed to these other terms. Now we're going to have negative 12x cubed. Now we're going to have a negative times a negative. So we're going to have positive 4x to the fourth. And if we clean that up, it looks like we could write this as positive 3x to the fourth minus 12x cubed minus 7 over x to the fourth plus 7 all squared. Now again, maybe also they might actually FOIL this out and get x to the 8th plus 14x to the fourth plus 49, but they could just leave it like that. All right, onward. Let's look at 26. We're supposed to derive and plug in. So again, we've got a kind of chain rule problem going on here. When we derive, that inside derives to 2x, and cosine derives to negative sine. And you've maybe seen me do this in notes, but if I'm going to get negative sine, I'm just going to push the negative out front here and then have the sine, just to kind of not have to rewrite things twice when I'm cleaning stuff up. And remember, the original inside goes back into the derived cosine. All right. So that is f prime, but now we need to plug in the root of 3 pi. So here we go. We have negative 2 times the root of 3 pi times sine of the root of 3 pi squared. And if you square a root, you just get the inside contents. Oh, whoops, it's minus pi. Minus pi. All right, so from there we have negative 2 root 3 pi times sine of, let's see here, that'll be 2 pi. And now we probably need to figure out what sine of 2 pi is. Now 2 pi is when you take a full loop around the unit circle and then you say, what's the y value? Well, the y value is 0. So that means this whole thing is 0. And that means the entire thing is just 0. Because the trig 0, anything times 0 is 0. So we kind of did all that work really caring about the root of 3 pi and thinking it was going to be a bad time just to get 0 and have it not even matter. So that was convenient. Hopefully that happens on the test as well. Up next, we have average rate of change, and that should be a gimme question. But again, this is the no calculator portion, so that can be kind of annoying to have to plug in 6 here. Maybe what we could do, I'm just kind of thinking here, because we might not want to cube 6, although I believe it's, what is 6 cubed? Should be 216, I'm pretty sure, but let's say we wanted to plug in 6 a different way. Here's something you could do. You could factor out that x squared. That might make our numbers a little easier to work with, so, or maybe not, I don't know. But now we're going to plug in 6 to figure out what the value is. When we plug in 6, we get 36 times negative 5. And if you never knew this trick, if you're multiplying something by 5, you're really multiplying it by 10 and then cutting it in half. So in other words, we have negative 360 cut in half, and that's negative 180. So you can still kind of do that in your head. Also, don't forget you could do 36 times 5 the old school way. So you'd get 30, and then that would be 15 and 18, and look at that, 180 with a negative. Anyways, that's h of 6. We also need h of 2. That one I think I can get away with doing in my head. You'll get 28 from the 7x squared, and you'll get negative 2 times 8. That'll be negative 16. And so it looks like h of 2 is 12. And so now we're finding the average rate of change again. So it's y2, negative 180, minus y1, 12, all over 6 times 2, which is 4. It might be nice to, we can do this in kind of a few different ways, but that's negative 192 over 4. But that doesn't look too easy for me. I think what I'm going to do is I'm going to divide these right away. If you didn't know, there's actually 4 45s in 180, so this is really negative 45 minus 3. So evidently, you'll get negative 48 as your average rate of change. The last question for this part of the study guide walkthrough will be 28. Now it looks really, really awful, but remember, we're trying to find the equation of a tangent line. So because of the way they've written this problem, thankfully, because they've given us the x and the y coordinate, they've actually already done a lot of heavy lifting for us, because the equation for the line tangent is y minus y1 equals the slope times x minus x1. So that looks crazy, but the idea is you might be able to eliminate a few answer choices just by knowing that y minus y1, x minus x1 idea there. So really, the hardest part here is we need to figure out what the correct slope is. And maybe before we do that, because this will show up again, let's just maybe say, what if they didn't give us the y value here? And what if we had to figure out that when you plug 5 ln of 8 into this crazy function, you get 18? Let's just review that, because it's going to show up in our derivative too. So how on earth did they end up getting 18? Well, they had 2 times e to the 5 ln 8 divided by 5 plus 2. So what happens there is our 5 over 5's cancel, and now this reads as 2e ln 8 plus 2. Now, long story short, if you have 2 to the l, or if you have e to the ln of something, e to the ln just cancels out, so we just have 2 times 8 plus 2, and that's how they got 18. So that's just showing you, again, why the y value is 18. Now let's derive and see why we wanted to review that up front. When we get g prime, we've got a chain rule here. You're going to have to derive x to the 5th, which is 1/5. That's going to stay multiplied to the 2, e to the original expression, and the 2 at the end drops off and derives to 0. So now we need to figure out what the slope is. We need to figure out this missing piece at 5 ln 8. So we have essentially 2/5 times e to the 5 ln 8 over 5. And we get a similar story here. 5's cancel. Now e and ln are like to the power of each other. And so they're just going to cancel out. So we have 2/5 times 8. And so it turns out the slope is 16 over 5. And we put that into our equation, and we're done. Now, you might have to distribute the 16 over 5, and you might have to move the 18 to the other side, depending on what your answer choices look like. But hopefully you see, I know it's not fun when ln and e's show up, but if that's true, try to review those skills again. Maybe look at some other